Oh. Okay, that one's working. That one's working. Hey, when is it ending? Bro, just read the... Reki, I know you know how to read directions, dude. Just go read the announcements. It says when it's ending. What's up, Mistral? It's very simple. Yeah, read the fucking manual. Thank you, Sensation. Kids these days. I don't know when it's ending, but I wrote it down at some point. It's sometime in August. Oh, man. Why can't it find my stream? Yeah, there you go, Ricky. You'll figure it out, dude. I believe in you, dude. Okay, whatever. I just can't see my vertical for whatever reason. I swear I could. I don't know why I can't add this. One sec. This should be working. Let me fix this. I do an update, everything messes up. Developers. I'm about to go to like the old social stream, honestly. Okay, yes. There we go. Now it found it. There we go. Okay, Mistral, you're in. Good. Okay, I think it works now. Oh, we get some hearts. Thank you. Okay, cool. All right, that one works. Oh, my. I have the fan on because it's getting hot. My closet is starting to heat up. What are we at? We're at 81 degrees right now. 81. What's up, Hasib? Sib says, hey, Dr. G, I was wondering about the regrades. I got a lot of points taken off on question 9 because I put 13.2 instead of the actual R1 distance. And this got taken off for all 3. Yeah, sure. So that's an example, Sib, of something to, yeah, send me an email about. Yeah. If you want to, if it's like one error you made that like kept persisting in multiple parts of the question, again, if I could take a week to grade them, and then people would be mad that they're not getting their exams back. But for now, I just do like a cursory look at partial credit, and I just give it. And if you think that's a very good example of where, like, yeah, I could probably give you some more partial credit, just detail it out for me. You know, help me help you. That's what I say. Yeah, don't get scared. What's up, Nick Kunch? Yeah. My boy. Okay, cool. Welcome to Office Hours. This is the stream where we help you out with any sort of like math homework, science homework, whatever like is going on in life. We're here to help. I have quite a few students from UCLA who are taking a physics class with me, and so we help them out as well. Whatever. It's either I need to crack there or something else. Why doesn't he just ask you in person? Because my course is completely online, Equity. That's why. Yeah. Yeah, I'm not teaching a... I would have loved to have taught an in-person class this summer, but just not how the dice rolled. Okay. Whatever. I have to make some sacrifices. You have a birthday? Happy birthday, Hasib. Yes. Miku says, hey, can you go over the process to question 9 on the exam? Totally. Let me do that. Let me do question 9. I think that's a good one to do. I forgot about the stage. I did. Thank you, Sensation. Sorry. Yes, bring Sensation back. Where are you, Sensation? You here? Where you at, brother? And here, let me. I think I should be able to share my screen after installing that external antenna. I haven't had any bandwidth issues, Sensation. So I seriously think it was my bandwidth, dude. That's what it was.
I stand by my codec hypothesis.
You think it's OBS? I think it's my bandwidth, because once my bandwidth started doing better, we stopped getting issues.
This is all.
Jeff says, wait, if you can teach UCLA remotely, does this mean I can teach from another city? Sure. But I don't think UCLA would hire you to teach remotely unless you, live in LA. I taught in person last quarter, and so they know who I am, and so now they want me to do things online. But I guess technically, yeah, you could do whatever. Why isn't Sammy working today? What the hell? Sammy. One sec. I need to know why Sammy's not working. Token isn't expired, dude. I fucking hate, dude. I hate that Twitch makes you re-authenticate your tokens every 30 days. It's so annoying. Like, Jesus. Why?
Rude.
Rude. Fucking hate it, dude. Wow, okay. Okay, now it should be working. Okay, cool. Alright, yeah, let me kick things off by helping out the UCLA kids out with, let me do question 9 from the exam. Hey, there you go, 1270.0.1. Yes, take me home. Take me home, Sensation. Home sweet home. Oh. That's dope. That's dope. Where'd you get that shirt?
That's dope.
That's super dope.
Germany? Everything comes from Germany these days.
Yeah. The Germans do make good stuff. Like, chemicals and things.
What's that about bees?
What's that about bees? Okay, let me do this one question. I attend your lectures, so my stream streak doesn't vanish, not gonna lie. Oh yeah, sorry, I forgot about y'all with stream streaks. Yeah. Well, hopefully you're learning something too. Coming by the streams. Learning some physics, That's cool. Let me find exam 1 where it's at. Okay, cool. All right. We'll start the stream and then we'll do some announcements. I have a lot of stuff that happened in the server, but let me help out UCLA real quick. All right.
That's dope.
Welcome everyone. Office hours. My name is Dr. Skull. This is Actual Education. Stream will help you with math homework, science homework. Yes, Shantrix, I fixed it. There was no animation because Twitch is a cuck and requires me to renew the token every 30 days. So stupid. Anyways, okay, here we go. All right, let's do this one. Question 9. What's up?
Hold up. The couldn't says, what's 1 times 100? Use a fucking calculator.
Nick, good to see you too, man. You need help with math later? Let me help you out for sure, dude. Yeah?
Can you hear me?
Barely. Yeah, boost your volume, dude.
Oh.
There you go. That's better.
Oh, wait, that was better.
Yeah, didn't you pass your track worker exam, dog? Aren't you gonna be a track worker now?
I don't know. I don't know when they're gonna call me. If they're even gonna
But I thought you got a really good score on it, right?
Yeah.
Okay.
But you gotta wait until they decide.
Okay. So he says.
If there's one thing the US needs, it's definitely more mass transit like trains.
Yeah, we do need more trains, dude. 100% need more trains. Okay, let's try to do this one. Has to do with decibels. Where's my equation for decibels? Yes. That's with intensity. Yes, okay, cool. Okay. This is the equation I need. And then I think intensity goes as P over R squared. I think that's the other thing we know, right? And then, what is it? I1. Okay, well, I is equal to P over 4 pi R squared. So then, I1 over I2 is equal to, so that's going to be P1 over 4 pi R1 squared over P2 over 4 pi R2 squared. Yeah, no, we totally can. Yeah, if I can get like, yeah, you want me to do like a big chat room or something? Yeah, totally. Yeah. Yeah, because you guys are just typing. I get it. You like to talk. Yeah. I thought most kids are like afraid of their voice, but yeah.
Good job.
Yeah, let me see how to set that up. I gotta do like a big chat room, I guess. The whole reason I'm doing any of this and not doing Zoom is just because UCLA can't figure out how to give me a Zoom account. And it's so annoying. I'll pester them more. Yeah, totally. Okay. I was gonna say, Sib, if you want to talk like right now, you can join our Discord, because that's how like Sensation's talking to me right now. Yeah, you can just like create an account on Discord. You can join Discord, and you can like come on the stage here, and you can literally just talk.
And be the cool kids.
Yeah, you can be with the cool kids. Yeah. Yeah.
I've never been either of those things.
Yeah. Zach says, I think the open broadcasting is awesome. Yeah, I think it's cool. The kids actually like it too, honestly. I was reading up on, well, let me not like out people with their names and stuff. One sec. I have a screenshot of it real quick. Wow, I'm learning how to use the technology. The technology is great. Yeah. So yeah, if you join that Discord, whatever, and then go find the stage. It's called Office Hours stage. And then if you say like request to be speaker, Sensational will let you up, and then you'll have a mic and you can talk to me. Yeah, we love that. Yeah, Sensational. He'll do it. Yeah, someone was saying on Campus Wire they really liked the YouTube stuff. Yeah, this was it. One second.
Your stream is lagging a little bit.
Stream's lagging?
Yeah.
Which one? Twitch or what?
Discord, it's cutting off a tiny bit.
Oh, that's okay. Yeah.
It does that anyway.
Yeah, Discord's just a piece of shit.
That's not a gold problem. That's a Discord problem.
That's
been
a
going on for
skill
long
issue,
time.
dude. Skill issue. Yeah, but no, one of the students said this. They said, what was it? They said, oh, being able to drop questions in YouTube chat and Campus Wire at any time is really nice. Yeah, I was like, cool. Yes, dope. Love that. And then someone said this. I love the feature of rewinding live during lecture that comes with YouTube Live. So I didn't realize this was an advantage over using Zoom, but YouTube has a DVR feature where they can rewind the stream live while it's happening. Like they can like be like, oh, I didn't get that, go back, and then they can like fast forward through it again. And so this isn't something, right? Zoom doesn't have this shit. So yeah, Twitch adding rewind when, yeah, it's I didn't know it's apparently called DVR. I had to like check it on the features. And it's wicked cool, I guess, for the students, because when they're learning, yeah, sometimes I say something like, wait, what did he say? Or like, ooh, does that make sense? And they can just go back. Yeah, cool. But I get it, Sib. It's also nice to, talk to people. So yeah, if you want, you can come into Discord and we'll talk. Okay, but let me do this question. So, some information we need. So it says we're at a music festival, and you notice the music from the speakers at the front of the stage, located at location A. Let's locate it right here. Is really loud. Use the diagram information below to solve the following problems. So we say the stage is 3.41 meters wide. So if this is 0, this is 3.41. And then positions B is 12.5, C is 17, and then D is 25.9. Using a phone instead of your actual... Yeah, but everything's mobile friendly these days, Sensation. Everyone just loves mobile, dude. It's the one dude, bro, I mean, look at our streams, right? I get so many more people on YouTube vertical than I get on horizontal. It's just like, yeah. It's just... We're moving towards like a phone landscape. That's just what it is.
Actually, that's not entirely accurate.
It's not entirely accurate. Okay.
The latest figures show that people are actually going back to the old phones.
Oh, okay. We're going back.
En masse, which I kind of find interesting. The only problem is people aren't replacing them with other pieces of technology, and so we're going to end up with an entire generation of people that don't know how to use technology again.
Uh-oh. As long as they're not eating Tide Pods, I'm fine, dude.
Yeah.
Okay.
That was an interesting part of the internet, wasn't it?
Yeah, and those people are now like employed. Like they're in the employment sector right now. Okay. So, okay. Your friend is located at B and measures a loudness of 114 decibels. Okay. So, decibels. Yes, the amount of decibels they read. So, whatever. We can call this like dB, I guess. Fine. Let's call this like dB. dB1. Let's call this like dB1. Yeah, friend 1. dB1 is equal to 114 decibels. And then, what should your X be such that the loudness drops to a much safer decibels of 100? Okay, so... Right, because 100, I think, is the limit for, like, long exposure. You don't, like, fucking blow your eardrums out. So, we're located some distance here, X, and I want dB2 to be equal to 100. Yes, we can get to that too, Catberry. Yeah, I'm doing question 9 right now from the exam we just did. Okay, so by this equation, right? If you want to do, for instance, so dB1 is equal to 10 log I1 over I0. This is like the threshold, whatever. So if I want to do dB1 minus dB2, that's equal to 10 log I1 over I0 minus 10 log I2 over I0. Okay. So we can kind of combine this. So I'm going to say dB1 minus dB2 is equal to 10. And then log of something minus something is the same as dividing them. So this is log of I1 over I2. And then this goes away. Because, yeah, ask me later if you need to know the math. But that's just, this is where log rules are important. What's up, 1K? Okay, so dB1. So originally, I was at 114 decibels, or my friend's at 114, and I want to be at 100, and this needs to equal 10 log I1 over I2. So this is 14, and then divided by 10, so that's going to be 1.4 is equal to log I1 over I2. So then I1 over I2 is equal to 10 to the 1.4, I think. Right? Yeah, okay. All right, but that's the intensity. But I want to know distance. So the other thing I learned about distance, right, is that I1 over I2 is proportional to... Oh, I fucked this up. No, I did this right. Sorry. It's inversely proportional to the square of the distances. So I1 over I2 is R2 squared over R1 squared. And we did that from this, assuming like the power of the source is the same, which it is. It's the same speaker. So this is equal to R2 squared over R1 squared, right? Oh, it's being paywalled? God damn it, Twitch. Trying to get everyone to go with like, what, Twitch Turbo or something? Like, stop. Yeah, you're ready. You're welcome, Vasabi Sivaramakrishnan? It's a cool last name.
That's extreme.
that's pretty extreme, yeah. Is someone tell me who's Indian here? Like, I know there's like a caste system. Does the length of your last name correspond to like whether you're a Brahmin or something? Is that real? Someone told me that at some point. Okay, R2 is the distance you're at, so that's gonna be X squared. We're looking for that. R1 was the distance, and this is the distance from the source, okay? The source is right here. That's the key thing. Oh, it doesn't 1K? Okay, cool. So, key thing. For this case, where your friend is at R1, it's not at position B. It's not strictly 12.5. It's 12.5 minus 3.41 in this case. You have to subtract the distance between the speaker and where the person is. So this is 12.5 minus 3.41. You'll see the first videos. Oh, that's really cool. Okay. Nice. I didn't know that, Jeff. Do we think Twitch will make it to the fall, though? Aren't they, like, hemorrhaging money? They keep firing everyone, right? I looked at a job at Twitch. I looked at maybe getting, like, hired to, like, do stuff with education there. But then they just started laying everybody off. And I was like, okay, never mind. It's like, uh-oh, nope. Honestly, I think the whole snafu they had with, like, the hot tub stream fiasco, I think that kind of, like, really fucked them. Like, they kind of flip-flop between, like, what was acceptable content and what wasn't. And they just kept doing that back and forth. I forgot. You are right. I forgot to square the bottom one. Thank you, Aleph. I messed up. Yes, thank you. Well, you know what I'm gonna do? I'm gonna just multiply it by it again. Okay. Now I'm gonna take the square root of it. Calculators are allowed. Yeah. This test was open everything besides AI. I said no AI. You can use your notes. You can use a calculator. You can use a book. Just can't use AI. And then I designed certain questions that if you did use AI, like I know you did. I have a couple students I'm pretty sure used AI. I'm just like I'm biding my time before I start like accusing people. But for the majority, everyone did a pretty good job here of staying mostly honest. I was happy. Okay, x is equal to 6.75. Okay, but that's not x, right? And also, like, wait a minute, this is like really off. One sec. Did I do something wrong here, Aleph? 10 to the 1.4 is that, right? It should have been a big number, dude. What? Wait, what? Dude, what? Excuse me? Oh, I already took the square root. Oh my god. I'm losing it, dude. I'm sorry. Yeah, you didn't do the subtraction. Yeah, that's the key thing, Mistral. Yeah, you had to, like, when we do this equation here for this, it's the distance from the source. The source is located here. Yeah, a little tricky. I had to make things a little tricky. Yeah, no, I fucked up. I square rooted 2 times. Anyways, okay, so x equals 45.6. That's the distance from the speaker, right? But I wanted x as the distance from, like, the back of the stage. So then I have to re-add the 3.41. So then I do this and I say plus 3.41. And that should have gotten you, 49 meters, which, yeah, right answer. Okay, so yeah, 49 meters. So, like, total distance equals, like, 49 meters. So, actually, let me not write this as x. I should have written this, sorry, as, like, R2. This is R2. And then x is equal to R2 plus. And this is R2 plus, whatever, where the speakers are. We'll be testing a small number of viewers later this summer, help refine the rewind feature. What's a small number? Yes, I'll get to that, Aleph. I got to help UCLA students first, but then I will get to that. Yes, don't worry. Cool. Does this make sense, Mistral? For part A, at least? Was this good? In the bag, as we say. For some epsilon, dude, don't bring epsilon delta into here, dude. Don't do it. I'll do part B and part C if you want that as well, Mistral. Just let me know if I can do that as well. How do I know how many points I got ticked off for each part individually? I only know the whole number. Yeah, you don't, and 40. That's the issue. Yeah, no, I mean, this is the fucking issue with Kudu, is that it lumps all the points together. So, just ask me about that. Just ask me to, like, well, here's what you should do. Yeah, regardless of, like, you can't see the YouTube chat. The YouTube chat's right there, right? Can you not see that? YouTube chat is also, it's here, but it's the bottom corner. Yeah, way down at the bottom. That's the YouTube chat. It has YouTube and Twitch on it. It has both. But yeah, sorry, Mistral. yeah, just email me about that question and explain to me what you did and what you think you should get partial credit wise. In general, if I saw something that looked vaguely correct, I gave half credit on that part, right? If I looked something that was on the right track but just didn't get the right final answer, rather than give you 0, which is what Kudu would have done, I at least gave you half credit. So if you got every single thing wrong, like you didn't get the right answer, like Kudu gave you 0, 0, 0, then you probably got 15 out of 30 for that question, because I gave you 5, 5, 5 for each part. So, just, yeah, feel free, email me, and as long as you do it this week, I'll get to it. Also, I figure it's like it's a good exercise for you to kind of like reanalyze what happened and try to understand where you went wrong and like how to do things better. I thought about not grading the exam at all. Well, just having Kudu grade it and then telling everyone, okay, I'll let you get, 70% of your points back if you do corrections. But then that's a mess because A, that's more work on your point, because then everyone's doing corrections. And then I have to grade all the corrections. I was like, no. Not doing it. So what I did was I was extremely generous with partial credit. And if it's kind of, so that, I'm not forcing everyone in the class to do work for the baseline partial credit. But if you want extra partial credit, then those students that want to take the time, go through their exam, figure out what they did wrong, and maybe fight for a few points, then yes, I will help you out with that. And please don't. Some students were like, I don't want to waste his time with silly things. You're not wasting my time. I mean, I'm a teacher. That's the whole point here. If you feel like you understand what you did wrong and it was a small mistake, like it doesn't harm to try. If you drew a fucking picture of Elmo and you're saying give me partial credit, that's wasting my time. Don't do that. But in general, if you did it, yeah, don't give them ideas, right? Dude, some of the kids on my my spring quarter class, yeah, they would literally draw me cartoons at certain points, and I'd give them half a point or something. I'd be like, okay, you did something. Yeah, full credit if it's good enough. Well, no, it has to be the right answer for full credit. Yeah, you get full credit if you got the answer completely right. Partial credit is if you didn't get it right, but you understood what was happening, and can justify for instance, if you had the completely right answer for part A, but say you slipped on B and then you did it right in part C, but it was using the slipped values from B, then instead of you only getting half credit for part C, I'd give you 90% credit, or 80% or whatever. Oh, full credit for Elmo. Did you see Elmo's Twitter got hacked yesterday? Did you see that sensation?
Oh, I heard about it. Yeah.
Yeah. Right. Well, one second. Little detour. Sorry. Little detour. We got to talk about Elmo. This no. Aleph, this stream is not only for UCLA. It's just primarily. I get priority. What is it? You can ask whatever. What is it? Elmo? Because obviously, if this was only for UCLA, I can't be looking at Elmo's Twitter. Oh, Sesame Street's Elmo shared anti-Semitic posts. Dude, what? Oh my god. All right, that's too much. Okay, we can't. I can't actually go into that. I thought it was just being funny. I didn't know they were going full fucking crazy with it. All right. Dude, why am I getting phone calls?
You don't know then.
I don't know. I don't know what.
Loads of the top 5 streamers have been proper horrible bastards.
Oh yeah.
And bringing on actual terrorists on their streams and stuff like that, and waving guns around and all sorts.
Oh,
and
no.
Twitch is going, yeah, we don't care because you're all in support of Palestine.
Wow.
The kind of stuff that would get you arrested in any other country in the world.
The divide is going too far, dude. I can't. Just leave Elmo alone. Leave Elmo alone. But yes, Mimi
idiots. That part of the world is nowhere near you. And even if it was near you, it's not your country. Leave it the fuck alone.
Gays for Palestine is always the most hilarious thing. I crack up at that one. It's hilarious.
Because
all right, let me just
throw you off a building immediately.
Yeah, they don't support you. Question 20. I'll get to that. One sec. Let me do part B for this one, okay? Because, yeah, someone asked about question 9. I will do everything today. If you hang around, I will do it. Just don't worry. It's Monday, I get it. Busy day. Okay. So from your safe spot, you decide to run towards your friend and make it to point C in 3 seconds. If you're singing along yelling at a constant frequency of 2 kilohertz, and so is your friend, what is the corresponding beat frequency that your friend would hear from the 2 notes overlapping? Hint, first compute the frequency your friend hears from you. Assume the speed is found as 343. Know the finals? What do you mean know the finals? I want to play the... Are you talking about the video game? I love the finals, but... Okay, so the first thing they say is that you come from here and you start running towards point C, and you do so in 3 seconds. Okay, so you're way out here at 49 meters, and you run towards point C, which is located at 17. And then your friend is at 12.5. So this is friend. Ooh, maybe tonight, Fedekai. I might play some tonight. I don't know. I'll see if I have time. I have a lot of emails I gotta deal with tonight now. Now that I opened up like regrade requests, my inbox is getting flooded. Okay, cool, good. And it says, okay, the beat frequency. Okay, so let's analyze like why there is a beat frequency. Okay, this person, right, is singing out loud at 2 kilohertz. Okay, so they're emitting a 2 kilohertz sound. Okay, but your 2 kilohertz sound is going up in frequency because you are moving towards your friend. So your friend observes you as another source, and that is a source that is moving towards you. So that means there's going to be a Doppler shift. So this frequency your friend hears from you will be different than the frequency that he is emitting. Someone did make a good point here. Technically, you can't hear your own sound. Like, you only hear the sound reflecting off of other things, but I was like, don't get that complicated. It's okay. So here, let's calculate the frequency heard by you. The frequency from you heard by your friend. So for that, we need the Doppler shift equation, which, where is it? Doppler shift equation. This is it. F0 is equal to F source, and then it's V. It's like plus or minus VO over V minus plus V source. Your bones conduct the sound. Yeah, but I someone go research that for me. Go or ChatGPT it. But I'm pretty sure you don't hear sound. I think your ear, that when you hear yourself talk, I think it's still from the reflections on like other rooms. Have you ever noticed when you talk, it sounds different based on like what room you're in? Right, obviously, right? You talk in like a church or something, there's like an echo. Or if you talk in like one of those like mental asylum places with like the soundproofing. Your brain edits out the regular sound you'd normally hear. That's what Jeff says. Okay. I'm not a biologist, so I don't know what circuitry our brain does. But okay. So in this point, you are the source. I feel like this is like a motivational thing. You are the source. And you are moving towards the observer. Okay, but you have a velocity. How fast are you moving towards the observer? Well, you know you get from here to here in 3 seconds, okay? So the velocity of the source is going to be 49 minus, this is where we have to remember a little bit of kinematics, right? So the difference in positions divided by 3. So let's pull it up. 49 minus 17 divided by 3, so 10.67 meters per second. Okay, that's cool. All right, And that 10.6 meters, okay. And then the friend is now the source. So we say friend is source, not food. And that has, sorry, friend is the observer, not food. And their velocity is equal to 0. Okay, so let's do this. So the frequency heard by the observer is equal to the 2000 from you as the source. And then we know that's going to be, this is 0, so that's plus or minus 0, so I don't care. And then this is going to be V. The question is it minus or plus, right? Think about this. If the source is moving towards the observer should hear a higher frequency. And to get a higher frequency with stuff on the denominator, I need a smaller denominator, which means I need this to be a minus. So this is going to be minus 10.67. And then V, we were told, is equal to 343. So now we can do some math. So you have 2,000 times 343 divided by 343 minus 10.67. And that gets me 2064. So F0 is equal to 2064 hertz. Okay. That's the frequency that the observer hears from you. But we wanted to know the beat frequency, right? Because your friend's singing in 2000. He hears, or she or whatever, hears you at 2064. So the beat frequency is the difference of them. So that's 2000, whatever, minus 2064, and then absolute valued. So, yeah, 64 hertz, which I think was the answer. Is that what we got? 64.1, cool, good enough. Yeah, the tolerance on Kudu should have been at, I think I set it at 5%. So as long as you're within 5% of the final answer, you're correct. One sec. Aleph says, you should be able to hear your own sound through bones. They are rigid, so energy losses are lower. That's just a brain thing, like the inversions of image. Yeah, that is always a cool thing. Like, our images in our brain are flipped. And then our brain flips them again. It's how, like, that's an optics question, which you will learn in Physics 1C. Okay. Does this make sense so far for part B? I forget who was asking this one. I think Mistral did, but then also Mikiyu asked this as well. Yes, cool. All right, and then here, let's round out. Let's just finish it off. If you did the subtraction in A, okay, cool. So Mistral, that's a case of, yeah, if that's, you had one error in A and then it carried over in B and C, just document that. Write me up like a nice little email. Be like, it also when you're doing this, like, please use screenshots of your grade scope work. Like, be like, I don't know, take a screenshot, highlight it, and be like, hey, look, I messed up here, but then I used the same number here and here and it would have been the same. And then that's the best way for you to help me to help you. And then I'll give you whatever points I can for it. Cool. Oh, Priyana! How's your summer going, Priyana? Priyana's a student from our, was it Physics 5A class I taught? Yeah, Priyana, this is Physics 1B. They had their first midterm on Saturday, so now I'm going over the exam. It's a totally online course, too. I hope your summer's going well. Are you taking any summer courses, Priyana? Oh, that's okay. Ooh, molecular bio. Have you taken Orgo yet, Priyana? That's the hard one. That's the one everyone gets like messed up on. All I can say is ni hao. What's that, Omega? Now instead is assume that instead of your friend remaining stationary, they also run to meet you at point C and get there in 3 seconds. Oh, okay. Oh, so your friend runs at point C and also gets there in 3 seconds. Okay. So let's see. This velocity was equal to 10.67 meters per second. And then this velocity is going to be... Is this at 17 meters? Sorry, what did we say this was? Yes, okay. This is going to be 17 minus 12.5, and this is also over 3 seconds. So let's get a new velocity for that. 17 minus 12.5. And then that's 1.5. Yeah. I'm sorry, Aleph. How is your future getting ruined from another country? Is it all the H-1B visas? Because I mean that is like a thing that's happening. Okay. So now we want to know the beat frequency. So this is why this is a cool question. Is before we had a stationary observer and a moving source. Now we have a moving observer and a moving source. Okay. So F source is going to equal F0, and then it's going to be V. In this case, because this is still now the observer, and this is the source. Because the observer is moving towards the source, they should hear a higher frequency. So this is going to be plus VO, and then this one is still going to be V minus VS. Yeah. Doppler effect. Yeah, it's a double Doppler effect almost, right? Yeah, because you have two different things that are moving. So this is 2000, and then this is 343 plus the observer, which is 1.5. And this is over 343 minus 10.67. Let's see what we get. Three, 4, 3 plus 1.5 divided by 3, 4, 3. Yeah, Fedekai says, I was wondering how much time we should have taken on this exam since I feel like the concepts are not the setups are not complex but tedious. Yes. So if this was a normal and one second, let me get this real quick. Let's see. FS or no, sorry. This is F observer equals FS. What I'm fucking up. Okay. FO equals 2073. So then the beat frequency is 73 hertz, which it was. Nice. Cool. Okay. But yeah, Fedekai, your question. So the entire exam should have taken like an hour and I would say 15 minutes. The way I structured this one, it was slightly more intensive, I guess, than my usual 50-minute class. 1.5 meters per second running, yeah, it is walking. However, no, I understand. I understand that, like, for instance, the reason why we had, like, all these numbers, right? And they're all, like, kind of weird decimals, and, like, we had to have you read diagrams and all this stuff. This, unfortunately, is a side effect of giving an exam online. I can't make things like straightforward, easy, nice numbers because then it's too easy for students to just copy paste that amongst everything else. So unfortunately we do have to make it like quote unquote tedious, but that's to like ensure that like every student has to like do a unique set of things. If you are all here in person, I would make the diagrams, the numbers and everything a lot nicer to work with because I wouldn't have to worry about someone getting on a Discord and being like, oh, the answer to question 9 is 4 meters, and then like everyone just writes 4 meters. So it's a side effect, unfortunately, of it being online, is I do have to make it tedious. But that being said, I mean, I appreciate the feedback. I really do need the feedback because that tells me for future exams to make sure there's enough time for you guys to do it. In this case, I think it's like I gotta like double what I think would be a reasonable amount of time to do it.
I've got a great idea.
You have a great idea? Sensation, what's your great idea?
You hire out a small pub. And then you just get everyone to go to the pub.
Bro, dude, I have students in China. I have students in India. I have students like on plane flights like across like Tajikistan or something, dude. It is one of the funniest things teaching this online course. It's international. Everyone's all over the place. VR hub. Yeah, we could do VR hub, I guess, right? That's what Fedekai's saying. We could use VR hub. So yeah, I understand. It took a long time because you were punching in numbers. Totally get it. Maybe I can look into ways to make that not so painful. Unfortunately, what it does is I tell Kudu, like, here's the equation, and here's what the answer is. Come up with some random numbers. And the problem is, like, Kudu doesn't know to come up with, for instance, like, nice numbers that just, like, do nice math. I will say one thing. If you are taking a lot of time, quote unquote, punching in numbers, the way to solve that is to not punch in numbers until you get to the very, very end. Okay? So when you are doing, and you're going to do this throughout your career, and if you continue doing like physics or engineering or whatnot, you want to try to keep things as variables. The longer you keep things as variables, the less numbers you punch in the calculator until the very end, and then you get a final answer. If you're carrying like decimals and stuff like throughout all this stuff, it sucks. Yeah. Exactly, Aleph. Yeah, derive the formula, put in the values, 100%. I agree with that. What's up, Rue? Good to see you. How's life?
What math are we doing today?
We're not doing math, actually. This is physics. This is college level physics. Are you in college yet, Rue? Didn't you graduate? You graduated high school, yeah?
I'm not going to college. Not
What?
Until, I'm not going to college for a while.
Okay.
Not until
Well,
I get military stuff going.
oh, military stuff. That's cool. What were you joining? What were you thinking about joining?
Air Force. I already
Air
have my
Force.
paperwork signed.
At least it's, yeah, what's the one everyone makes fun of? The National Guard or something? Or the Coast Guard? One of them they make fun of a lot.
No, Space Force.
Space Force? That's a thing? We have Space Force?
Yeah.
Oh my god.
What do you mean we have Space Force?
I didn't know we have Space Force. I thought that was like a TV show. Is that not a joke?
No, Space Force.
No, we have Space Force. Ah! Oh man. That's hilarious. It's the newest branch, Zach says. Okay, cool. The Space Force is the newest
Yeah.
branch. What are their uniforms? I want to see.
The newest
Oh, wait.
branch.
I remember they got in trouble because their uniforms look exactly like Star Trek uniforms. Bro, this is ripping off Star Trek to a fucking T. What? Stop.
It's so funny.
What? Go to Space Force. Yeah, what? It's literally the same logo. Dude, no. Dude, what? You can't do that.
Terrible.
You can't just rip off Star Trek. Plagiarism Force.
Trick Force.
Oh, that's too funny. Okay. Oh, apparently 9,400 people though. I think part of the Air Force. Yeah, wait. So Space Force is part of the Air Force though. Yeah, because I had some buddies in the Air Force that were thinking about like, I guess, whatever, side transferring or something.
Yeah, it's so weird. It's where the nerds go.
It's
They
where
don't
the
go
nerds.
to NASA. They go to Space Force.
I'm a nerd. I'd go to Space Force. That sounds pretty
I
cool.
know.
Hell
I'm
yeah.
gonna make fun of you for it.
Yeah. There's no air in space. Okay. Cool. Nice. Well, good to see you, Rue. I'm gonna do a couple more physics questions here and stuff, but you're always free to like hang around. I'm glad I saw you. I'm glad you came by the server again. We've missed you. You know. Go tell Ian
I
he needs to
know,
go
he's
back to
very
fucking
great.
school and get his GED.
I was on the phone with him the other
Yeah.
day.
Yeah.
He called me like out of the blue,
Uh-huh.
and he just ranted to me for an hour about like 3 different chicks. It was terrible.
Yeah, he's down bad, dude. He's down bad on the girls. This happens. He was such a bright, smart kid too in high school. He had a lot of potential. I mean, he still
know.
does. But yeah, he's a very smart math guy and whatnot, but just got like wrapped up in the typical teenage
He got wrapped up in the worst
a
thing.
lot of stuff. Like one of his friends got shot, like I don't know, there's a
Yeah.
bunch of people getting arrested. I don't know, it's just
He's been going through it in general. But
okay. Well, I'm glad you're being a supportive friend for him. Like try to remind him he's
Yeah, of
smart.
course.
He's smart and like he should go finish his high school degree and like get out of like gangbang Houston that
He
he's
was
in.
talking about it. He was talking about trying to get his GED.
Good.
Who hasn't finished high school? Huh?
Yeah, go yell at Grim, dude. Go shame him. Go shame Grim. Tell him that like he needs to get a
Oh
fucking
my
high
God,
school
is that
degree.
Dark?
Yeah, that's Nick.
Hi.
Yeah, Nick's
Hi,
still here.
Nick.
It's a reunion.
I forgot he
This is
existed.
here too.
Nick, yeah, Nick definitely exists. All right, let me see. Yeah, Rue, come by the weekends and stuff. We'll play games and like chill and stuff. I gotta help kids with math stuff, but I love that you came by.
Math stuff scripts.
Nice. Okay, for the UCLA people, what was so I did question 9 here for you guys. What was the other one you guys wanted me to do?
11.
What? 11? Someone said 11? We don't have a question 11 on here. It only goes up to 10.
Is it 11?
I gotta find my chat. My chat's like, there's so many chats. There's all these chats. Question 11 on Gauss's law. Okay, cool. Let's do it. Let me go find it.
Vaping in a semi-UCLA stream is crazy, as opposed to you, who clearly needs to be in a padded room.
Vape. I mean, what? They're consenting adults. I mean, I don't believe in vaping. I think vaping's fucking dumb. But it's okay if Sensation wants to vape. I don't mind it.
Stiggies are worse.
I mean, hot take. I do tell people like, just go smoke cigarettes. Like, stop it. What are you doing? These like Chinese cancer death vape, blueberry, peach, raz, ice fuzz. Yeah, well, I mean, yeah, it's just. But these people want nicotine. I get it. So I'm like, just go smoke cigarettes. Like, at least it'll be inconvenient for you. The problem with vapes is like you wake up in the morning. I had like friends like this where like they just wake up in the morning. They're just vaping in bed. I'm like, excuse me. Like, it used to be inconvenient to go get nicotine, so like you'd have to like step outside and like, so it decreased the amount you were doing it, the volume. All right. But to each their own. It's okay. I have vices. I got plenty of vices. Don't throw shade if you're afraid of the dark. I'm not talking about you, Nick. All right. Here we go. Question 11. Ooh, this is a fun one. Okay, so we got Gauss's law 11, electric fields 12. Here, let me just write this. Sorry, somewhere in my chat. Gauss 11, electric 12, and then exam 10, part B. Okay, cool. All right, let me pull this one in. Inside a ball of radius r, charged with uniform charge density, P of r is constant, there's a spherical cavity that carries no charge. The center of the cavity is a distance a from the center of the ball. Find the field strength at point P inside the cavity. Oh, that's cool. Dun, dun, dun. Oh, and then it depends on things? Interesting. No, this is a weird... Okay, alright, one sec. Let me think. Let me think about this. Homework is difficult. You got it on a test? Only R charge density? What do you mean R charge density, Aleph? Field strength, I want to use Gauss's law, I think, right? I want to use, like, right? E... EDA is Q enclosed. Over epsilon not. The issue is... Take it as a ball with no hole and a small ball with negative charge. Right, okay. Oh, and then put the two on top of each other? Is that what we're saying? Can you what is it, superposition? Sorry, superimpose them? Oh. Oh, that's cool. Oh, that's fucking wicked, actually. Very cool. Okay. Yeah, okay, so this is a trick, Catberry. Okay, cool. Yeah, I didn't think about that, but that's smart. Wow, and we got Ash in the chat. What's up, Ash? Okay, let's say, for instance, you have this, which has positive charge on it. Okay. And then you have a ball here, okay, that has negative here. Let's say this has a positive charge Q tote, okay, right? The total charge on this is equal to Q tote, and then this has an amount of minus Q1, which is the same amount this trick comes into use everywhere. Cool. Which has the same amount here, but it's the negative of what's here. So that if you were to take this, for instance, right, and place it on top of here, you'd end up getting a net charge of 0. And that's the same thing as there being a cavity, right? You see how it says there's a cavity that carries no charge? Okay. So we're going to figure out what the electric field would be due to this, and then what the electric field would be due to this. Okay? So if we were to do... Right, let's just do of the big cavity. So let's say like E field... for big sphere, okay, is the charge density, oh, it's linear. Nice, it is linear. Okay, cool. All right, fine. So that would be E times 4 pi, and then this would be R minus A squared. Right, okay. Is equal to, I think this is Q enclosed, which is going to be 4/3 pi R cubed. I think, one sec, let me see, okay. Oh, let's not do the R minus A yet. Okay, sorry. Yeah, okay. Let's just do for the big sphere. Because then, I get it. 1 second. Okay. E times 4 pi R squared is equal to Q enclosed over epsilon naught. And that's going to be equal to, Q enclosed is going to be 4/3 pi R cubed times rho over epsilon naught. Okay. So this is going to be E is equal to 1 over 4 pi epsilon naught, and then that's going to be 4/3 pi R cubed over R squared. This will cancel with this. 4 cancels with this. Pi cancels with this. Oh, and there's also a rho. So this is equal to rho over 3 epsilon naught times R. Okay? So this is the electric field anywhere in this red sphere, which is the total thing. Okay? So now let's figure out the electric field for the negative small sphere. You think I did it wrong? Well, I haven't done it completely yet. We have to superimpose them later. Yes, it is, and that's what I did with this, Aleph. This is the volume enclosed. And this is the volume density. Does that make sense? Double check my work there, Aleph. Oh, you're not cut. Oh, it's okay. Okay, cool. Okay. So this has a charge density. We say like, do they call this rho equals constant? Let's just call this like rho naught. So here you have rho is equal to positive rho naught, and then here you have rho is equal to negative rho naught, right? Because then, I mean, this volume is the same as this volume. So if the charge density here is negative and the charge density here is positive, then the enclosed charge will cancel each other out. Imagine how fast God has to figure this stuff out when we observe it. Okay. All right. So let's use our diagram here. This might actually help us. Let's see this. So the negative sphere is here, okay? Now, we're going to do E times, and then here for 4 pi r squared, this is going to be 4 pi, let me think. I think this is r minus a, right? So if this vector is r and this vector is a, r minus a is this. Do you see like how we're building new Gaussian surfaces here? This is r minus a. And that's going to be equal to 4/3 pi r minus a squared times negative rho, okay, to give it negative charge, and this is over epsilon naught. So, 4/3 pi r cubed, right? So r minus a, this is like the small sphere radius. So what it's telling me is that my electric field, if I was a small sphere and I was negatively charged, right? If I go a distance away from the center of this small sphere, which we could call that like S, for instance, that distance is technically the same thing as R, where I'm measuring the electric field reference to the big center circle, minus A, because A is the direction from the center of this circle to the center of this circle. So R minus A gives me the distance of my new small Gaussian surface to the center of my small negative sphere, the center of it. Okay. 4's cancel. Pi's cancel. And this is going to give me left with E is equal to R minus A, or negative R minus A rho over epsilon naught. Oh, and there's still a 3 here. Yes. Okay, cool. Okay. So now I have it for the big sphere. I have it for the negative sphere. I think I just superimpose it upon itself now, right? Yeah, okay. So now we do E total, which is equal to this one, right? So we're going to have this plus this. Why does R minus A work? Okay. So, consider we're just looking at a small sphere. Let's say we're just looking at the small sphere. Oh, good. Isn't there a direction associated with it? Yes, there is. You can't just subtract the magnitudes. But you can break them up into components. So, okay. Really what this is this is R vector minus A vector. Do we agree with that? Like, R vector minus A vector is S vector? Yeah. Yeah, sorry. I was being, yeah, okay. This is also R vector, right? So, we agree for this one, right? That the electric field here points in the R vector direction, or I'd say like R hat, right? And then Cadbury here, right? Yeah, you're right. It is pointing like in all of these directions, right? But for every direction here, I can rewrite that as another vector R minus the A vector. Yeah. No, I mean, good call. Good call. Because now the nice thing is like this cancels with this. Right? And I'm left with a minus minus, right? So that's just going to be A vector rho over 3 epsilon naught. Which, yeah, I think is one of the answer choices. Yeah, it's answer choice A. Yeah. You got to be rigorous with kind of your vector calc, unfortunately. Yeah, so this is the correct answer, right? A rho over 3 epsilon naught. Jaden, in a second, I got a long line of people I got to help. Yeah, maybe later. Yeah, I'll stream for at least another hour and a half. We're going pretty long today. Awesome, cool. This is a good question, actually. And I forgot about this trick of that you can superpose positive charges with negative charges, and that creates cavities. Brush your teeth. Isn't vector calculus just vectors? Yeah, it's also called like multivariable calculus. It's, yeah, calculus in a bunch of different directions at once.
It's like, can you help me later, says Jaden? But specifically.
Jaden,
I asked you that question for a reason.
Jaden is in Malaysia, I think. So I don't know what time it is in Malaysia. Yeah, speaking of international, right? I have a bunch of international students, or not, they're not international students, they are just currently in international places. But then even just within our Discord, we have like international people all over the place. Okay, electric fields number 12. What homework was that? There it is. Okay, electric fields. Load, please. There we go. Good. Ooh,
What are we waiting
ooh, I found it. Okay. Taylor series expansion? Excuse me? Oh, no.
Oh no.
U.S. government announces $200 million Grok contract. Wasn't Grok just making a bunch of statements about like Mecha Hitler? How did they approve that? Oh man. Okay. I don't know, dude. We live in clown world at this point. I don't know. It's just like government's doing whatever the fuck it wants at this point. I think we're just gonna wait 4 years for a reset, and I hope to God the Democrats learn to run like a decent candidate instead of like trying to prop up a fucking dead zombie and then last minute throwing in a unlikable person with a not so squeaky clean past. Okay. Question 12. A point charge is located at a distance from a thin ring of radius r with uniform charge density minus q. What is the electric field at a point lying on the axis of the ring, a distance x from a center? You can use the Taylor series expansion for the small parameter r over x is less than or equal to 1. Oh, okay. Okay, so if you got a ring of charge, and you're trying to figure out, and it's uniformly, right, it's minus q. Minus q, so that means that lambda is equal to minus q over 2 pi r, right? Charge density. Oh, I see. There's 2 charges. Oh, and then you got a positive charge Q here. Oh. Ooh. That's actually really cool. Okay, let's just... Well, we know for a point charge, right? What the electric field is. That's pretty decent, right? So, let's call this, like, charge 1, charge 2. So, E field from charge 2. That's just going to be... Electric field due to a point charge is 1 over 4 pi epsilon naught Q, and that's going to be over x squared, right? Are we cool with that? Electric field for charge 2. And that points... Whatever, let's call this the z hat direction. Z hat direction. Okay. Doing the ring of charge. That's like doing all this, right? Do you want me to rederive how to do the ring of charge? I don't think it's too bad. You basically say that you basically try to like imagine like a bunch of little point charges here. And then you notice that the electric field from them will cancel out in this direction. And so you just take this is like theta, which is also the same as this. And you only want this component. So that would end up being like E cosine theta. Or let's say like E1 cosine theta, right? So the electric field from like a point charge here would point this way, but it would immediately get canceled out in this direction by the symmetric matching mirrored other charge on the top end. So what you can do is you can integrate 1 over 4 pi epsilon naught, and then it's dq over r squared, and then we're going to say cosine theta, right? So this would be the electric field total, okay? Pointing in the r hat direction. But then what I do to be clever is I notice that electric field will only eventually have components in the z direction, because anything this way and anything like in and out of the page will cancel out due to the symmetry of a ring. So instead of writing r hat here, I'm gonna write this as like cosine theta z hat. Okay, and then we assume this distance here is r. Let me use a different color for this. So then also, okay, if that's r, this is x, and this is the square root of r squared plus x squared, right? So that means that cosine of theta is equal to adjacent, so that's x over the hypotenuse, which is the square root of r squared plus x squared. Okay, cool. And then this is also... Oh, this is cool. This is also equal to r, little r. So little r refers to this distance. It's the distance from, like, where I am on the ring to where I'm measuring my electric field. Okay, this is E2. And then we do this from, like, 0 to 2 pi. And then this is, like, r d phi, I think. Yeah, which I think you're allowed to then just say this is equal to 2 pi r times lambda. So okay, yeah, when you integrate over dq, because the electric field here, the contribution is gonna be constant all the way across, this whole thing can come out. So now this is 1 over 4 pi epsilon naught. 1 over... Oh, wait, no. No, I messed up. Sorry, because... or did I? No, I think I'm okay. No, I'm okay. Because this is d phi. We're not integrating with respect to dr. Okay. 1 over 4 pi epsilon naught. This 1 over r squared x over the square root of big R squared plus x squared. And then it's integral of dq, but integral of dq is just going to be minus q. Yeah, that's another way to do it. You're right. Okay. Okay. And then r squared is the same thing as big R squared plus x squared. So you get 1 over 4 pi epsilon naught, and then it's like xq, and then it's 1 over r squared plus x squared, square root of r squared plus x squared. Okay, cool. So this is equal to xq over 4 pi epsilon naught, and then it's big R squared plus x squared to the 3/2. And that's equal to E2. So this is in the z hat direction. This was also in the z hat direction. Or sorry, this is E1. Sorry, this is for the ring. E2 is the point charge, my bad, sorry. Okay. This result right here, this is a very common thing. You should be familiar with this derivation. I think the hard part of this is the Taylor expansion we're gonna do later. But ring of charge electric field. If you ever want to see, like, yeah, the derivation for this, this is it. Maybe they got a cool video. Let's go check out the video.
The hardest part about a writing assignment is getting
Transform
started.
your papers with AI. Okay.
Now we're going to try and find the field.
Dude, I love this dude. What? He's got a bow tie? Excuse me?
By a ring of charge. A point here, the component will be this way. If I pick a component over here, it'll be this. In this
Yeah,
case,
okay.
A and X. Have to make this conversion from K to 1 over when A becomes much, much bigger than X. Well, if A becomes much, much bigger than X, depending upon what you feel most comfortable with. Now,
Okay. I hate how blurry this is because it was 11 years ago. Oh man.
welcome to
I wish
Online. And
he has a good explanation of it. It's just it is long. It's long to do this derivation. Maybe this helps? Yeah, this is also it as well. So, like, do we have to go through the whole derivation for the ring or skip to the formula? On a test, since that's like a pretty well-known geometry, the ring, you could skip right to it. That's totally cool. Unless I specifically say derive it, but I don't know why I would do that. I don't know. I don't think tests should be derive this practice sessions. Like, what? Like, do that on your own. That's on the side. Like, tests are like problem solving, and like this is a very well-known derivation. I definitely invite you to work through this and make sure you understand the calculus of how this works, because it will come up in other classes for sure. Doing these like symmetry arguments. So it's a great exercise, but you know, if we're going through a competition where I'm asking people to, I don't know, like lift a car, I'm not gonna also ask you to like show me how much you can like curl. Like, I care about the application of what you're doing, not like the training. Yes, deriving is a good form of problem solving. It's cool. It's a good puzzle. The difference is, like, for a test, Aleph, especially if it's an open book, open note test, this is a garbage question because you just copy down the derivation, right? That being said, you should understand how this derivation works, because if something were to change on it, like, let's say, for instance, the charge density was not uniform, or we were asking for the electric field, like, somewhere else, you still want to know the same problem-solving techniques to be able to do it another way. You've never given an open test? Yeah, well, this is online. I can't enforce a closed note test. I just can't. It's impossible. Anyways, okay. So, if you want, later, at another point in time, I can go through this derivation again. But for now, just take my word on this, like, quick derivation I did for it. This is the electric field due to the ring of charge. This is the electric field due to the point charge. And now you add them up, okay? So now we say E total is equal to 1 over 4 pi epsilon naught. And now that's going to be Q over X squared. And then this is minus, sorry. Minus QX, and then this is going to be over big R squared plus X squared to the 3/2. Okay. But the thing says, use the Taylor series expansion assuming R over X is greater than 1. Okay. So what they're saying is assume that the like size of this disk is much bigger than like how far out you're measuring the electric field. What could I change? I could change the charge density to not be linear, or like not be constant. I could have it be like a function of, I don't know, like the angle or something. That would kind of suck, but I could do it. And then you could also make it not perpendicular to the center, correct? Yeah, Aleph brings up a good point. You could ask for the electric field like over here or something. That would be really hard, Aleph, no, wouldn't it? Man, because, like, wow, that would, like, mess up some stuff. This symmetry is really nice for this one. Okay, so we say R over X is greater than, or is much greater than 1. Okay, so that means X over R is much less than 1, right? Yeah, it's a lot of vector calc, Aleph. I don't know if I'd want to do that to students. That's like really mean. I think what I want to do Let me think how I want to do this. This is already well known. This is the thing that needs to expand. Right? Thank you, Pink Rose. I'm nice? I hope I am. Okay, let's look at Taylor expanding this. And let's only Taylor expand the stuff with X and R in it. I don't care about the Q, right? So that's X, and then I'm going to say R squared plus X squared to the 3/2. I think we have an expansion for like 1 plus something, 1 plus X squared. Is that the one I know?
Oh, that's a question. Do GED prep?
GED. That's I mean, I can help. I don't specifically do it, Pink, but Pink Rose, if you have like a GED workbook you're going through and you have math questions that don't make sense to you, you can totally ask them during the stream and I can like teach them to you.
Yes. Start with the English.
Yes. English is okay. 1 plus X to the N is 1 plus NX. Where's that one from? Where is that from? Which Taylor expansion is that? I have ln of 1 plus X. Where's that other one? Where'd you get that one, dog? What?
I don't even know what you're doing.
You're welcome. He says, trust me. Yeah, but I want to pretend I'm a student, you know, and I don't have like the almighty God Aleph just whispering in my ears like what to do. What would I do? If a lot of times when I do these, I don't like rehearse this stuff. I want to show you guys like live as a student, like what I would do to try to figure this out rather than just like spout off facts. So I would be like, I need to see some known Taylor expansions that are like cool. I know that one, 1 plus X to the N. Where the fuck is that one though? Where is it? Is it? See, they don't even put it here. That's not like a common one. I know the 1 over 1 minus X. That's a geometric series. I know e to the X. That's an easy one. Oh, is it the binomial expansion? Oh, okay. There we go.
It's all Greek to me.
It's not a Taylor series? But they said to use a Taylor series. You can use the Taylor expansion. Yeah, okay. Let's like maybe try to explain why this is. I'm actually kind of curious about this. Yeah, this is a binomial expansion. This isn't a Taylor expansion. Or maybe it is. Okay, one sec. Let me just, I'm going to educate y'all in the chat if you've never heard of a Taylor expansion. They're really cool. I keep pulling up my fucking physics class. Okay, here we go.
Here's a quick public service announcement as to why physics is so useful.
Why is physics so useful?
You need to know.
Sensation, do tell us.
Because then you won't try and brake check a fully loaded lorry.
Yeah, you won't like put too much weight on it.
What's an unloaded lorry? 18 tons?
That's a lot of weight, dude. 18 tons? No way.
I'm pretty sure an articulate lorry is 18 tons.
Holy shit, that's really big. Okay, let's say f of x is equal to 1 plus x to the n. Okay. Then f prime of x would be equal to, right, this is a chain rule, right? So you bring this down, it's n 1 plus x to the n minus 1 times the derivative of what's inside, which is just 1, right? Okay. And then f double prime of x. Do you understand, Sib, how I'm doing this? This is a calculus thing. Like, this whole thing is like, kind of like u. And the derivative of like something to the n, right? U to the n is n, u to the n minus 1. But then it's a derivative of what's inside, so. Alright, cool. Just making sure. So then when you take a second derivative, right? This is n minus 1, 1 plus x to the n minus 2. Okay. Okay, cool. So a Taylor series about a certain point. So we're going to do it around, around 0. We're going to take the Taylor series around a equals 0, which means whatever's inside here, x should be small. X should be about 0, right? For when you take a Taylor series expansion, you always want to expand your Taylor series close to where you're trying to estimate your number. So, for instance, if you're trying to approximate some... Here, let me show you this. This is actually really cool. If you're trying to approximate this blue dashed thing, right? You need to pick up... And let's say you're trying to figure out the value of this thing around... I don't know, yeah, around like 0.1. Then what you want to do is you want to layer on top of it polynomials that fit this black function around there. So this looks like it was centered around here. So that means my Taylor series, which is a sum of all these different polynomials on top of each other, is pretty valid for finding values of the black function around where I built my Taylor series. It comes down to like knowing like what a Taylor series is. A Taylor series is taking like an irrational function, something that's like noisy, doesn't look nice, ugly math garbage, and writing it as a bunch of polynomials of higher and higher orders stacked on top of each other, like superimposed on top of each other. But where you start stacking those polynomials on top of each other kind of dictates where your new like Taylor series thing is valid at predicting values. So in this case, if I'm taking a Taylor series around a equals 0, I best believe that like f of x, that like this x is also like pretty close to 0. So if I take the Taylor series around, this is mean we're gonna get like f of 0 plus f prime of 0 over 1 factorial x minus 0 plus f double prime of 0 over 2 factorial x minus 0 squared, right? And so let's see what that is, right? So f of 0, that's 1 plus 0 to the n. That's just 1. Okay, so cool. So this is going to be 1. F prime of 0, that's going to be n times 1 plus 0 to the n minus 1. But 1 to the n minus 1 is just 1, so that's just n. And then over 1 factorial times x, so this is x. And then this becomes n minus 1 over 2 factorial x squared. Okay, and so forth. So I think like the next one would be n minus 1. You start seeing a pattern. N minus 2. And then this would be x to the third over 3 factorial. Here's the cool thing though. So, and this is where Aleph is right. If the value of x, that you're looking at in our Taylor expansion here is small. So if x is like less than 1, like pretty small, pretty like a fraction that's pretty low, then x squared will basically be 0, and x to the third will be like 100% 0, right? Imagine this was like 1/8, right? Imagine it's like, for example, x equals 1/8, right? Oh, well, now x squared equals 1/64th, and now like x cubed is equal to, I don't know, 1/512. Or no, is that right? Yeah. It just starts getting like really fucking tiny. And so eventually, these terms here, we do this in physics a lot, Sib. We just get rid of them. We just say they don't count in physics because they're like not significant. Roman, can I ask a piece of advice from you as a tutor to tutor? Sure, yeah, what's up, dude? Yeah, ask away, dude. Okay. Cool. Oh, do you see how this is the same thing that we were getting from here? That's cool. Do you see that, Jeff, right? This is a binomial expansion, but this binomial expansion comes from a Taylor series, I think. That's really cool. Fuck, that's dope. Okay. So, here's the known expansion. What's a Taylor series, by the way, Pink? Oh, this is a calculus thing. A Taylor series is a way to approximate like weird looking graphs in terms of like simple graphs, you know. So, for instance, some simple graphs, you know like this, this is like y equals x squared, y equals x cubed. And you can like put these on top of each other to kind of estimate like what a weird shape looks like. It's a way of like, yeah, estimating stuff. Okay. Sib says, yeah, they're really cool actually. Yeah. Yeah, if you want like a cool like little visual thing of it, just look up like visual Taylor series explanation, and someone will show like a really cool graph of how it works. Or like I'm sure someone's done something on YouTube. Sib says, I got it because we don't need it. We are approximating the function and giving it characteristics that represent it, like the derivative and an x minus a function. The function, we're approximating the function and giving it characteristics. Oh, 3 blue, 1 brown has the best video. Oh, go find me the link if you can, Aleph. I'm curious. Yeah, and that's this is college physics, Pink Rose, but they use a lot of college calculus in it. But yes, you're right, Sib. Yeah. If you need like a refresher on Taylor series, it comes up a lot in physics. We do a lot of Taylor series, and you should know kind of the common ones. Roman says, thing is, I have to teach a group, and like I have a very smart guy and a very stupid guy at the same time. How should I deal with that if I don't have the opportunity to separate them? It's interesting because Sensation says just give them beatings. I don't know if I can recommend.
Oh no,
I can recommend that.
It's not a particularly useful recommendation, but it's mine.
Yes, that's Sensations. Yeah, the Sensation is beatings. But yeah, what I would, because I dealt with this with my last quarter class. I taught a college physics class where some students had never seen physics in their life, and some kids had already seen it in high school. Like they'd already been through it. So I wouldn't say like smart and dumb, but I had kids that like really knew what they were doing already and kids who had no clue. And my solution to that is to make things and teach things at the level of the lowest common denominator, or like the average. So I would teach things to people based on the fact that they had never done physics. But in order to keep the people who are really not, smart or like whatever, had already seen it, I would create bonus questions for them and give them points if they could solve it. But I would tell all the other students, hey, don't worry about this. Like, if you don't get this, that's totally okay. It's not going to hurt your grade. But if you do, like, it's worth, and I didn't make the bonus worth very much. It was like a point or two. So like, something's up with what, really? Yeah, it's fine. You guys keep.
It's fine here.
Yeah. I don't know what's up with you guys. I'll restart the
Interestingly
Discord.
enough,
Yeah.
he's talking and I can't hear him, so it's them, not us.
Yeah. Yeah, I don't know why that is. Nick and Shaq. I'll restart the Discord server. Let me finish this question real quick. I do teach at a college. I do. I teach at UCLA. Okay. What was I doing? Okay, sorry. All right, so yeah. We're going to Taylor expand this. What I'm going to do is, okay, I know R over X is much greater than 1, so I know X over R is much less than 1. Or is that what I know, right? Is that what they said? Oh, R over X is much less than 1. Oh, I have this backwards. CULA? What's wrong with LA, Femvox? What's up? Are you coming to LA, Femvox? Are you coming to say hi to us? Yeah? Okay, now I can hear you, Shaq.
Yeah.
Sorry. This is what I want. R over X is much less than 1. Can we do a weird U sub integral? Maybe. I have kind of a queue of people. But if you want to follow, like, subscribe this channel the next time I'm on. Also here, I'm going to give my calendar real quick for people. So if you want to know whenever I stream.
You're getting off?
Yo.
No, I'm not. No. Nick, don't worry. I'm not getting off. I will help you. Don't worry. I'm just telling.
Hello?
Yes, I can hear you, Shaq. I can hear you, Shaq. Dog.
Finally.
What happened to your mic, dog?
Nah, it's you, bro.
I don't think it was me, dude.
No,
Anyways, this is our calendar.
Both of us couldn't hear you at all.
Okay. Well, I don't know. Something's wrong with Discord, maybe. Yeah. All right. Sorry. Let me just finish this question, then I'll feel good about things. R over X is much less than 1, so I would like for these things to have R's over X's. So what I'm gonna do is I'm gonna pull out X squared from here. His stuff's right there. Yeah, we are live on 3 different platforms right now. So actually 4 technically. So, but there's all the chats. I am on Google Scholar. Yeah, you can go find me if you want. 1 sec. Let me just give him my details.
That's what you and I should both do. We should really live up to our stereotypes. So, next time you have an official photograph taken,
What?
you should be just standing there with like pasta.
Like here, I'm the Italian guy. I like pasta. There you go.
And I'll just be standing there with like a bottle of whiskey in one hand and the bagpipes under the other.
Do you play the bagpipes? Oh wait, sorry. No, I got this
I
wrong.
used to.
You did?
I can't move my pinkies anymore, like properly, because I.
Oh, for the chanter? You need it for the chanter, right?
Yeah.
Yeah. There you go. That link there, Roman has all my thesis, my Google Scholar, whatever you want. Okay. I'm gonna pull it X squared. All right. So I'm gonna say this is X squared over X squared. Actually, no. Yes. Okay, yeah. All right, here we go. X squared over X squared. Okay. So now this is X. And then this is going to be X squared. And then this is going to be 1 plus R squared over X squared. This is to the 3/2. Oh, thank you. Okay, cool. Let me copy that link. Copy that for Rose. There you go, Rose. Check that out. It's a good video on Taylor expansions. Okay. So here's a cool thing. So I made this X squared over X squared, and then I noticed that both things had an X squared on it, so I can like pull that out. And now that leaves me with, it's really R squared over X squared plus 1, but it's the same as 1 plus R squared over X squared. But then this is all still to the 3/2. So now the 3/2 hits this. Oh, this is to the negative 3/2 too, by the way, sorry. Yeah, sorry, this is all to the negative 3/2. Oh, okay, I see. Okay, so then this is x to the negative 3, 1 plus r squared over x squared to the negative 3 over 2. This becomes x to the negative 2, so that's 1 over x squared. And then it's 1 plus r squared over x squared to the negative 3 over 2. This right here is 1 plus x to the n, right? This is 1 plus x to the n, which is equal to 1 plus nx. That's what we found from here, right? 1 plus x to the n is the same thing as 1 plus n to the x. 1 plus n times x, provided x is small. And x in this case is r over x, which is much less than 1. Yes, it is a binomial expansion, Femvox. I think it's also a Taylor series thing. So this is 1 over x squared, and now this whole thing is going to become 1 minus 3/2 x. Okay? Oh, sorry, not x. Well, x in this case is r squared over x squared. So here, this whole thing is like that. Okay. So now this, physicists are wizards with Taylor series. Yeah, they really are, dude. Okay. Cool. Okay, so that's what this part is. Dude, I love how we just did all this shit. Jesus Christ. Okay. All right, so now this whole thing here, this, because we took like all this, this now becomes minus q, and then it's over x squared, and then it's 1 minus 3/2 r squared over x squared. Right? But, yeah, very cool. So watch what happens here. So you get 1 over 4 pi. Thanks, Dom. Well, yeah, welcome to the Discord. That's a good way for you to figure out like when we're streaming. And then this is minus q over x squared. Oh, this is very cool. Plus 3/2 q. And then this is r squared over x to the 4th. You see what happened here? I just like multiplied this through. These two things go away. This cancels with this. And now I get e is equal to 1 over 4 pi epsilon naught. And then this is going to be 3/2 q big R squared over x to the 4th. Okay. Which is which answer choice? Oh, this is kind of cool actually where this comes from. Yeah. Look, here's the 3. QR squared, x to the 4th, 2 and 4 is 8 epsilon naught. Wow.
That's dope.
Wow, we did it.
Oh, we're so sorry to hear about your brother. That's all the way he gets stopped this thing. Boom! 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 Well done! Well done!
Okay, that was an absolute nightmare. But I hope that makes more sense to you, Sib. Yeah. I appreciate it actually running through it. I relearned the binomial expansion, which is basically a Taylor series. What's the acceptance rate at UCLA? Really low. I think it's like horrendously low now because everybody applied to UCLA last year. I don't know why. Well, I guess it's like the #1 public university in the US or something. Okay. Let me... Can you get in for a master's? In what? What are you trying to apply for, Aleph? Yeah, I mean, I'll tell you the graduate student acceptance rate was absolutely abysmal this year. I went to a town hall on that. So in my class, I think we had about 30 graduate students. This upcoming class for UCLA, in terms of like physics graduate students, has 11. They cut it insanely. It's really difficult to get into UCLA for grad school now, for sure. I think anywhere, honestly, in grad school is difficult. Okay. I think someone wanted me to also go through exam 10 part B, but I'm gonna take a little break from physics because we've been hitting it hardcore for the last 2 hours. How many degrees do I have? I mean, really I have a PhD. I also technically have a bachelor's. I technically have a master's as well, but the master's is like a consolation prize on the way to getting your PhD. Nick, you've been waiting really patiently, and I know I haven't helped you in a while. What can I help you now, real quick? What's up, Nick? Yeah, thanks for waiting for the last 2 hours while I just went through an absolute bender of physics. I will do more physics in a bit, or I will do it on Tuesday's office hours. I'm a little drained at this point. This is like, usually at UCLA, like office hours is 1 hour. They cut it at 1. It's just like you just do it, yeah. But we've hit this for 2 already, and like my brain is frazzed. Plus I taught today. Yeah. You can say something, Sensation? I am sitting here and talking. Physics. Nick, what's up? What were you gonna say? Do you have a math test coming up? You said you're trying to study for another career, or what's up?
Yeah, the court officer.
You're trying to be a court officer. That's cool. Government positions, dude. Okay. Do you have any questions that have been given to you, like practice questions for your court officer exam?
Yeah, I sent them all to you.
Thank you. You DM them to me,
The
or
ones that are together,
Oh shit.
yeah, DM. The ones that are together are all one question.
Okay. Let's do a couple of these.
Mm-hmm.
Gold, let me see if you want.
Don't neglect your fitness.
Don't neglect your what, sorry? Your fitness?
Fitness.
Yeah. Dude, I benched 275 today. Yeah. I 1 rep maxed 275. I got a video of it somewhere. Sorry. Let me go find it. Dude, Femvox. He's like, do you want to see some geometry questions?
275. I think that's how much I weigh.
Yeah, this is me. This is me this morning, dude. This was before lecture too. I was like hyped up on like pre-workout. Does this thing want to load today? God damn it. 1 sec. Yes, video. Okay, here we go. No, it wants to load. There we go. Yeah, this is me. You can do this. We're like, I can do it. 275 is like 2 plates on either side, plus a 25 on each side. I was just going for 1 though. There we go. Ooh, I make like a yell at the end. Yeah, it's cool. Anyways. Gym's great. Don't neglect your fitness. Go to the gym. And be smart. Okay, cool. All right, let's do some of these, Nick. These are fun. I like, dude, this, you know what this is? Like in a workout, this is like a burnout set. Like, I feel like with the last 2 physics questions I did, I was benching 275, and now I'm going up for like just like some high rep, like let's just do the bar for a little bit. I really appreciate these questions. Okay. If an officer's salary is increased from 480 to 540, that is a really bad salary. Bro, that's like fucking like 24 grand a year. I'm pretty sure that's like barely, but yeah, dude, you want to do the math, dude? What?
Weekly salary. I'm blind. Oh no.
That's weekly, dude. It's 4 weeks in a month. That's 2 grand a month. 12 months in a year. It's 24 grand. That is not good.
That's tough.
That's terrible.
That is tough.
That's tough. That's worse than a grad student.
McDonald's worse or?
Yeah. Okay. Anyways, what is the percent increase? All right. Do you know how to calculate percent increase?
I googled a lot.
Okay.
Yeah, now I do.
Well, I want you to like actually understand how it works, right? Yeah. Yes, Aleph, yours can be next.
You ask Google, it says to do 480 minus 540. You ask ChatGPT, it says 540 to 480.
Okay. Here's what you do. Okay, percent Rose. Sorry, I don't know why I wrote Rose. My brain's fried. Rose, these are good like GED math questions, by the way, Rose. Percent increase. Okay, this is always final minus initial. Okay. Divided by initial times 100. Okay, that's a percent increase. So it's the difference between what you ended up with and what you started, divided by what you started with, and then times 100. So, Nick, for this one, right? What numbers would you plug in?
So small, my phone.
Oh, you're okay. Bliat!
540 minus 480.
All right, 540 minus 480. Suka. All right, divided by 480 times 100, right? Okay.
Why are we all swearing in Russian?
I don't know.
I don't know.
Nick is Russian. It's fun to swear in Russian.
All right.
His grandma's usually like yelling at him in the background in Russian. It's just always funny. Okay. Okay, so this is 12.5%. All right, so which answer choice is that?
C.
Very good, dude. Very good, man. Nice. Okay. Cool. All right. Ooh, this is almost like a logic question. Suppose that, or here, and then I'm gonna do these on separate pages for you. Here, let me crop this one. Sorry.
We're talking about me.
Yo, what up, Grim? How's the? You know, Ari was just here. She was just we were talking about you. I was telling her that you were like trying to get your GED again. What's up?
She called me and she was like, "What are you doing?" I was with my girl at the time.
You're with your girl, dude. You need to be with your fucking GEDs. What you need to be with, dude. Chill on the girls. She said you've been through 3 girls in the last like 6 months.
That's cap. That's cap. I've been on.
I'm gonna tell you, dude.
It's my 8-month anniversary.
With the same chick?
Yeah.
You didn't like break up and get back together?
No.
Oh, okay. Congrats. Congrats, dude. I'm happy for you. How's the finding out a place to go? I know I sent you that one place and you have to be 21, which honestly, like you're getting up there anyways. But did you find anything else?
I talked to a college advisor and they gave me another GED site. I can schedule my test for like $35.
Okay, good. Yeah, wait, you just have to take a test and they give you the GED?
Yeah, you got to study and take the test.
Okay. Are you gonna study?
Well, yeah.
Okay.
It's easy as hell, bro. Anyways, I already took AP classes.
I know, bro. Yeah. This is what I mean. I was telling Ari this. Like, you're a very, very, very smart kid. Yeah, you already took like AP classes. You just got like caught up with like some bad people in high school. But but yes. Okay, great. Yes, take your test, pass it. Let me know when you pass it. I'll buy you some. Okay.
I bet. Shit, I gotta go back to work.
All right. Go to work. Peace. What's up, Mistral?
Can you ping me when we're back on physics? I want to go eat for a bit.
Yeah, you're good. Yeah. Let me see. I have 45 minutes before I have to go teach another student. So if it's after 6, it won't happen. But if it's before 6, I will. Okay.
Okay.
Cool.
Thank you.
You're welcome. All right. Pink says, this is interesting. I didn't know government officers had to study math. Yeah, this is like a, what is this? It's like a placement exam, Nick?
It's, I guess you can call it, but it's more of a, you need to take this test to get any government job.
I see.
Not this test, but I'm saying you need to take a test for every government job. Their own test.
Yeah, it's like in the military, you have to take the, I think it's called the ASVAB. But yeah, they do like test you on like your math skills to do things, because being good at math is
everything.
Pardon?
Your logic and everything.
Mm-hmm. Yeah, exactly.
If you're dumb, they don't take you.
Yeah, I wouldn't say that if you're dumb, but yeah, if you can't do math, then there's probably some other things that are wrong. Or not wrong, but like need improvement. So that's why. Okay.
They test you more of the logic.
The practical stuff.
Not the math. If you can't do math, if you have logic, you're fine.
Yeah. All right, well, I think this is logic. It says, suppose that 1/2 the officers in a department have served more than 10 years, 1/3 have served for more than 15, then the fraction of officers who have served between 10 and 15. Oh, that's cool. Maybe let's make like a little like graph about this, I think maybe. Let's do that.
Yeah.
So 1/2 have served more than 10 years. Okay, so let's do that. We'll say like this right here is 10 plus, right? And that's 1/2. And then this amount, right? Has served 15. And that's... Wait. Suppose 1/2 the officers have served more than 10 years. Oh, 1/3. Oh, sorry. Okay, here we go. Sorry. It's less. Sorry. Okay. That makes sense. Because as you serve more years, right? Wouldn't there be less and less people that do that?
Right.
But you see how, like, out of the people that have served 10 plus, right? Only some of those people have served 15.
Yeah.
Okay. So, between 10 and 15, right? So that means more than 10, right? But not more than 15. Okay.
Okay, I'm sorry.
What's up?
Repeat that again, I'm sorry.
Okay. So, for the ones that have served more than 10, this is half, right? For the ones that have served more than 15, this is 1/3, okay? So, if you want the ones between 10 and 15, right? Okay. I'm trying to draw this graphically. I'm having a hard time. Half. Oh, okay. Okay, here we go. Here's what I want to say. Okay, here's my axis, okay? We're going to say this is like years served, okay? And let's say this is like some really high value and this is 0, okay? We know that half of these people, right, have served more than 15. Okay? But only a third of these people have served more than 18. So this is 1/3. And this right here is 1/2. Okay? Does that make sense, Nick?
18.
Sorry. Oh my god. Dude, I'm having a stroke right now. Sorry. Oh my god. Oh, I'm fucking up, dude. Where the fuck did 18 come from?
What the fuck is this piece of shit?
I'm sorry, dude. Okay, here you go. I'm burnt, dude. My brain is burnt out. My brain is burnt out. My brain is burnt out at this point. So much like calculus and Taylor series and like. Okay. All right.
We still sleep well.
I gotta teach another kid fucking E&M at like 6, man. Yeah, I'm gonna be super burnt for this.
Oh, no.
I should take a rest. I think I will, honestly. I'm sorry to everyone, but I'm just tired. Okay. More than 10 is a half. More than 15 is a third, yeah? So we're asking for how many are in between 10 and 15. Do you see how that would be the full half minus a third?
Yeah.
So 1/2 minus 1/3. So that ends up being 3/6 minus 2/6 is equal to 1/6. So that should be the amount. C. Yeah?
Oh. Now I understand. Yeah, that's a good drawing.
You like?
Yeah,
Here,
that was.
Here, I'm gonna
That makes sense.
save these for you. Just let me save these for you. 1 sec.
Yes, please. That actually made a lot of sense. Thank you.
Good. I'm glad. All right, here we go. There's 6. This is Nick 7. Okay. And then here, I'll do 8. And then I'll look at a couple other questions from other people. But then come by the streams, you know, maybe wait like an hour so that I can like finish the physics kids so you're not like just chilling with, you know. Or I mean, you can also just like keep hanging around. I know you're probably not doing anything anyways, but like if you want to like just, I feel bad sometimes if people are waiting, but also you should kind of be learning from waiting, right? You know, doing something.
I'm trying. I don't understand half the things you guys are saying, but
dude,
yeah.
it's totally fine. It's totally fine. I tell students it doesn't matter if you're not getting like any of it. The fact that you're still getting exposed to it and like observing it. If you ever see it again in your life, you'll be like, oh wow, I kind of remember when that one weird gold dude on like the Twitch stream was like doing it. He was doing something.
Right? To the weird gold dude.
The weird gold dude. Okay. Oh my god, dude, these are logic questions. Okay, in a city prison, there are
this
4.
One I hate so much.
Bro,
I don't
what?
understand this shit.
Okay, in a city prison. Okay, alright, here we go. We're gonna draw a city prison. There are 4 floors. Okay, so like 1, 2, whatever, 3, 4. That's dope.
That's dope.
You're right, Femfox. Okay, the top floor houses 1/4. Okay, cool. This is a quarter. The bottom floor houses 1/6. 1/3 are housed on the second floor. The rest are had. Thank you. I do need to drink some water. Thanks, Sensation. The rest are housed on the 3rd floor. Okay. If there are 90, so okay, 90 inmates. Okay, this is easy. Okay. So you have a quarter, a third, a sixth, and you don't know how much here, right? Let's figure out what percentage of inmates are on the 3rd floor. Do you know how we might do that, Nick? Yes, Shantrick has the right idea. Nick? What happened to Nick? Uh-oh.
Can you hear me or no?
I can hear you now. I can hear you now.
Oh, okay.
Okay.
Yeah, I said no. I mean,
Okay.
I know what Chantrix is saying, because Googled it. ChatGPT gave me the answer, so I
Yeah.
understand what he's saying, but I don't understand how to do it.
Okay.
Yeah.
Sensation just hit me with the hydrates. Drown, motherfucker. He's like, make him drown with water. Make him drink so much water.
Why is it a minute apart though? You will drown under those conditions.
I will eventually. Too much water. Okay, so yeah, here's what it comes down to. There needs to be 100% of prisoners in all the floors, right? Do we understand that at least?
Together or each?
Together. Okay, so 1/6 of the prisoners are here, plus 1/3 of the prisoners are here, plus 1/4 of the prisoners are here, plus 1 something, okay? This is like, we're gonna say like plus X. This has to equal 1, okay? Does this make sense? Like, if you had like a half plus a half, you see how that's 1? Or if I had a quarter plus a quarter plus a quarter plus a quarter, that would be equal to 1. Or a half plus a quarter plus a quarter, that would be equal to 1. Yeah?
You hear me?
I can hear you now, yeah. It was cutting in and out. You're okay.
Yeah, I understand, yeah.
Okay. So do you see here how like a 1/6 plus a 1/3 plus a 1/4 plus some other amount, some other like fraction of the total population needs to equal 1, all right? We can solve for that, right? I need these all to be the same denominator. The same denominator is 12. So I'm going to say 2 over 12 plus 4 over 12 plus 3 over 12 plus X is equal to 12 over 12. This is 9 over 12 plus X is equal to 12 over 12. So that tells me X is equal to 3 over 12. Or 1/4. Did I do that right? I think I did. Yeah. Okay. So, Nick, 1/4 of the inmates are on this floor. We got that from this. Do you understand how we got there so far? I don't know what's going on with the mic these days. Oh, he's leaving. He's coming back. Try it again.
Hello.
I can hear you now. Yeah, good. Okay.
Yeah, which phones just now?
Okay. Do you understand how like 1/4 of the inmates are on this floor, on the 3rd floor?
Yeah.
Okay. But, so 1/4 of my total is equal to 90. How do I figure out how much the total is?
You divide 90 by 1/4?
Yeah, you do.
Oh.
Divide by 1/4, divide by 1/4, right? 90 divided by 1/4 is the same thing as 90 times 4 over 1. Right? Dividing fractions easy as pie. Flip the second, multiply, keep, change, flip. I don't know, whatever one of those. So the total is equal to 360.
Oh. Damn.
Yeah. So when we say like 1/4 of the total is equal to 90, you know that's 1/4 times the total. So if you divide by the 1/4 on both sides, you get what the total is. Nice.
Oh,
Good job.
we're so sorry to hear about your brother that passed away.
You get 5 big things, dude.
Thanks.
You're welcome, dude. All right, I'm gonna save this one. I'll send it to you. Come by the stream tomorrow, Wednesday. I'll help you out with more of them. This was
okay.
Nick. When do you have to take your test? Your court officer test?
September.
Oh, we got time.
It's September to October.
Okay.
For this particular test, you can choose your own day that you want. I'm gonna try to get the the earliest one.
Nice. Okay. Yeah, do it up. Mistral's got some good ones. Let me help out Aleph. Aleph's been chilling out here. He asked a question for a very long time ago. Aleph, you still in my chat? Oh, Pink Rose says, best of luck to you, Nick. Aw, that's nice. Thank you, Pink Rose. Join our Discord, Pink, if you want. You can hang. We're a cool group of people. Alright, let's see. What? Thank you for waiting, Aleph. I know it's been like 2.5 hours. Let's see. Oh, I probably need to tell you what our Discord is. Or, yeah, I don't know, somewhere. This one. Does this work? Does this one work? Did we fix this? Maybe we didn't. No, I need to turn on there you go. That's the Discord. Okay. Do you need help with number 8? Determine the moment of inertia of a cone with a half angle theta and a height L. Jesus, dude. These are the JEE questions. Shantrix, dude. I feel like this guy is you, but in physics form. Shantrix would always give me like the most ridiculous like math challenge questions. He's in Canada, so for him it's the Cayley exam and the Fermat one, I think. Oh, these are not JEE? Oh, they look pretty true. Okay. I just get worried because this is a 4-star question. I've never seen a 4-star question. It's usually a 3-star. 4? Okay. Alright. I need to remember what the equation for moment of inertia is. It's some integral. Yeah, I know it's mr squared, but like what's the... It's like r cross some whatever the fuck. Moment of inertia equation with calculus. JEE is like 2-star. There we go. Wait, no. Calculus in like 3-dimension. Yeah, here we go. Okay, first question. Is this an inertia tensor? Am I dealing with this? If I'm dealing with this, I'm gonna be in a very painful place pretty soon here. It is a tensor. Uh-oh. I'm gonna be straight up with you. I have worked with tensors like... I can count on my hands how many times I've worked with tensors. We'll try it though. What axis do they want this around? We don't have to use it, he says. Oh, okay. Alright. Let me draw what the fuck this shape is first, by the way. Sorry. It's a cone?
Hello?
What's up, Sib? How's it going?
Yeah, I just wanted to say I'll come back. Can you hear me?
I can hear you. Yeah.
Yeah, I'm gonna come back for the question if that's okay. I gotta go, but yeah, thank you.
You're welcome. Yeah, I'll probably do it tomorrow during office hours because I have to teach another student at 6 in like 30 minutes. So, but let's do it on tomorrow's office hours. Is that cool? Let's see.
And they gone. Oh.
Oh, no, she's back.
Goodbye.
Okay.
So janky.
Why is Discord fucking up today, dude? That's so annoying. I'm trying to help people today. Why does it look more complicated on DC? Oh, you're Pink Rose. What's up, Gina? There's more going on Discord. I can probably bump the resolution on this, actually. Sorry. Let me bump this to 1080 so you guys can at least see that. In a sec. Stream quality. There we go. 1080. Okay. Aleph Null can save us. Alright. YouTube is better? Okay. Enjoy YouTube then. Yeah, that's okay. Discord is useful if you...
is going on, Gold.
No, what's up? What's wrong?
Oh,
there's an echo.
it's echoing now.
Oh, man. One sec. Let me close the Discord stage and we'll come back. Okay. Better?
Yeah, I don't know what that was. It was picking up something from somewhere.
Yeah. I think it should be good now,
Can you
yeah?
hear me?
I can hear you. Yeah, can you hear me?
Right, yeah. What it was doing, it was picking up the broadcast because I could hear the music as well.
Oh, that's weird. I wonder why I was doing that.
Yeah.
You know, it does this weird thing where it tries to record the system audio sometimes, and I tell it not to, but that might have gotten triggered. Okay. Anyways, I'm so happy, dude. We haven't dropped any frames over this entire 2.5 hour stream. Look at these stats.
Antenna's working.
My antennas are working, dude. That's crazy. Yeah, look at that. I'm so happy with this. Look how many frames we have sent to YouTube. 278,000 frames. None of them have gotten taken out. That's great. What's up, Dark Arctic? Good to see you. I saw you in the Discord. Sorry, I had to restart the Discord. Okay, the mode of inertia with a half angle theta. What's a half angle? Ah, that is the half angle. Okay, cool. So that's just, I mean, I guess it makes sense. It's the half angle. You monkey. Dark Arctic is different than Dark Aspect. They're different darks. Okay. This is theta. And height L. Cool. About an axis A passing through its vertex and tangential to its surface. I.e., the axis and the height of the cone. Okay. So we're rotating at about this point. That's like super weird, dude. Okay. What's up, Minte? Okay. So I see things about like called like what is it? We say like the body principal axis. So I think that means referring to this as like our reference frame. So if I wanted to calculate IZ, for instance, that's the integral of ZDM And that's going to be from 0 to L. And, okay. Or is it Z squared DM? I think it's Z squared DM, no? Is that what moment of inertia is? Yeah, Z squared DM. And then what? As like... There's like a relationship between these, right? If this is R... this is equal to 0 to L... Z squared, and then DM is equal to... Wait, did they tell us anything about the mass? Don't I need the mass of this thing? Right? Oh, also, sorry, what is the volume of a cone? L over 3 pi r squared. Pi r cubed, sorry. Or r squared. Okay. So, rho is equal to 3m over L pi r squared. I would assume uniform density too. Correct. So, dm is going to be equal to rho dv, which is 3m over L pi r squared. That's rho. And then dv... I want to say it's pi r squared. Oh, I fucked this up, by the way. Sorry, this is on the bottom. Sorry. Oopsies. Yeah, because I need the pi r squares to cancel. There we go. It's that. And this is r squared. And I want to say it's dz. I feel like I might have to do it like a ds thing. Right? I'm tempted to do this. To do this dz. And then I make the relationship that R over L is proportional to R over R over Z, right? So then R is equal to big R Z over L. Okay, so maybe this works out. 3m over L pi r squared times pi big R squared Z squared over L dz. Can I do that? Cancel, 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 cancel. So 3m over L squared dz from 0 to L. Oh, you have to go? Okay, okay, all good. I'm just trying to find just the moment of inertia from the z-axis, just what this is. Then we can worry about, like, trying to tilt it. Yeah. I think I need 3/10 though somehow. They want 3/10. I get... And let's see that, actually. What is the moment of inertia? Moment of inertia of a cone. Yeah, this is what I wanted. This is what I wanted to do. Dude, look at the thumbnail for this. Ouch. These limits are not nice to work with. Euclidean, polar. Oh, it is 3mr squared over 10. Man, why can't I just do pi r squared dz? Can I not do that? It's such a bastardization. Oh yeah, then how do you tilt the axis of revolution? Yeah, that's the tensors. Okay, so this was already a bitch to begin with. Because, like, holy shit, I was going to have to do this. Oh, I see. I see. Sorry. Right, R is the distance from the axis of rotation. Sorry, it's not Z. So that's, yeah, that's x squared plus y squared. And then it's rho dv. And then you have to integrate what that little bit of dv is. Yeah, okay, no. Nope. I love you, man, but, like, Jesus Christ. Okay, cool. I am so cashed at this point. Dark Arctic, did you have a question? I see 1K's got one, Equity's got one, Shantrix got one, Reki. You want to post yours real quick, Dark Arctic? Because I haven't helped you in forever. So just send me your question real quick. I'll do yours and then... I'm sorry, I got to punt on the other ones. I'm tired. 1 sec, okay. Zach says, I never thought to do that before. You're motivating me to study this for a stream in the future. Have you not done moments of inertia? Yeah, this is cool actually, right? I like, dude, I love this thumbnail, by the way. This is a YouTube thumbnail, by the way. This is a really cool thumbnail. Someone put like a lot of good... This is aesthetically pleasing to me, Zach. Oh, tilting the axis to be an arbitrary line. Oh, yeah. Yeah, that's another way to do it. Yeah, okay, cool. Alright, what's up? Do you need to just like solve this? 16 sine of 10 degrees times sine of 30 degrees times the sine of 50 degrees times sine of 70 degrees times sine of 90 degrees? Oh, okay. Well, sine of 90 is 1. Unless this is meant to be something tricky. Because these are all going up by 20 degrees. Ooh, okay. Yeah, alright, let's see. Oh, sorry. Yeah, you're talking about like sum to product. Uh-huh. Or it's product to sum. This is a cool question. Yeah, so I'm thinking you want to... I don't know why your name is that. I don't know what's going on. Yeah, this is kind of cool. So I feel like... Oh, well, I don't feel like I just don't deal with this one. Sine of 90 is 1. But, yeah, here we go. This and this are the same thing. So, 1 sec. I need them to add to a number divided by 2 and subtract to a number divided by 2. 10 and 70 is 80. Yeah, and 30 and 50 is 80, but I think I want one to subtract and one to add. Let me think. Sorry, let me just think of the combinations. 50 minus 10 over 2 is 20. That's not going to work then. Okay. Maybe 70 minus 10 over 2, and then like 30 plus 50 over 2. Oh, yeah. Well, no, that's 40 though. Wait, nah. Because then this is sine of 30 degrees, sine of 40 degrees. I don't really want that one. Do I? No. I get it. I want nice numbers that I can deal with. $60 divided by 2 is okay. 20 is not. Yeah. 100, no. No. What if we get rid of the 30 and then just deal with these? 20, 140, 70, 80, no. 60, no. Ooh, okay. Oh, so you want like a nested sum to product, you think? Okay, alright, we'll get rid of this one. No, these are good ideas, Zach. I like these. These are good ideas. Take it or leave it. Okay. Okay, so... And whatever. I'm just going to pull the 16 out eventually. Because we have 70, 50, 30, 10 to deal with. Or actually, yeah, no. Just these ones to deal with. Because I also know this. Okay. $70 minus 50. Yeah, but I don't want to deal with cosine 80, 40, 20, 60. No. Yeah, you're working now. You're good. Oh. Sine of 2. Oh, you want to use double angles too. Oh, okay. I see. Oh, I forgot. Yeah, you can always cut down the half ones. This is cool. Yeah, you can cut these down too. Okay, where was this? Alright. Okay, so cosine of 30 minus no, sorry. Cosine of 50 degrees. Yeah, eventually. Yeah, give me a second here. Minus cosine of 70 equal to negative 2. And that's sine of... No. Yeah, wait a minute. This is 120 over 2. Sine of 20 over 2. Oh, that doesn't really help me, though. No, that's not what I want. Oopsies. I'm doing this backwards. Let me do product to sum. Yeah, this is what I want. I was thinking backwards. Because these are the ones we want to use, basically, right? So, sine 50, sine 60 is equal to 1/2. And then that's going to be... Or sine 70, sorry. 1/2 cosine of 120. Minus cosine of 20? No. That's the 50 and the 70. Yes, yeah, I can take out this one. Yeah, it's the 1050-70, which is interesting. I think I want this. I think I want sine of 10. Yeah, what if we do sine of 10, sine 70? And then that's cosine of 80, cosine of 60, right? And then I also still have... So I have this, and then I have sine of 50. You actually liked the other one? Yeah, because I'd like these to be... I would like these to be the same so I can get sine and cosine and then do a double angle argument, right? Alright, one sec. Oh, we've hit the max time on this. One sec, I gotta reload this. We've been streaming for too long. And I do have to go teach another student pretty soon here. Yeah. Oh, actually in 3 minutes I gotta go. Alright, last Hail Mary, I'm just gonna ask ChatGPT. Here we go. Is there a simple way to solve this one using trig identities? I'm just curious. I feel like there should be. I feel like we were onto something here, Arctic. It's a cool puzzle, though. Apparently the whole product is 1. That's cool. Here's the answer. I appreciate the struggle, but I do have to go teach. So, one sec. Here it is. Of course it's 1. Okay. So, yes. You don't need to deal with... We came up with this. You don't need to deal with the 90. You don't need to deal with the 30. And then you're just left with the 1050-70, right? Okay. The triple sine identity. No. Where the fuck did this come from? What? God damn it. What's the triple sine identity? Zach, do you know this one? Okay. I'm gonna say... Where the fuck did the triple sine identity come from? Okay, yeah, sure, then it's easy. Was this actually a question in your class? This is kind of crazy. Your teacher asked you this. You know, so... Okay. Here's using just the double angles. It's a lot longer. So, remove the easy ones. Convert the sines to cosines. Ooh. That's cool. So you have cosine 2040. Use the sine cosine double angle here. Keep doing it a bunch of times. Get an 1/8. Notice that cosine of 80 is sine of 10. And then you have an 8 out front. Oh, wow. Okay, cool. Okay, I gotta run. That's a good question, Arctic. Okay, cool. Alright, thank you everyone for coming office hours today. Sorry if I didn't get to everyone's questions. I had a lot going on. But, I will get to them tomorrow. I promise. Our next stream is tomorrow. That's at 4 o'clock Pacific. 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Make sure, yeah, if you have any other questions with, like, our friends and what's up, yeah, thanks, everyone. Yeah, I will get to your questions tomorrow. We'll do them. We'll do them. We have a lot of other awesome math streamers out here. Until next time, yes. Is it not working? Isn't that a command? Math streamers? Can I spell today? Well, it just doesn't want to work. Dumb. Okay. I don't know what's going on. There, okay, there we go. Now it's fucking loading. Okay, cool. Great job, Nightbot. Okay. I gotta go teach. Enjoy. We'll see you guys tomorrow. Oh, let me go raid someone real quick. Forgot. Go say hi to someone else who's streaming. Fizzbuzz, he's cool. Looks like he's doing some sort of this looks like math. He's got his cool glasses on. But okay, yeah, cool. Alright. We'll see you tomorrow.